The drawing that we have on the board shows the house of Mrs. Tahiti. The problem that she has is not having easy access to hot water. For this, she has to boil many kettles of water, and it's costing her a lot of money. What she does have, though, is free access to the energy from the sun. A solution to the problem that we have with not having easily accessible hot water could be to have a solar system installed onto our roof. The model illustrates a solar installation on top of a roof, such as the house that Mrs. Tahiti has. What happens is when the sun shines on the panel, cold water that is in the panel will rise up due to the thermosiphon effect and get stored inside of the storage tank of the solar system. Once it is stored in here, it is now ready for use by our consumer. During this experiment that we will do now, we will show how the thermosiphon effect works, how hot water rises when heated. To illustrate what happens when water gets heated, we will use potassium manganate, and a gas flame that we will use to simulate the energy from the sun. As the water in the container gets heated, purple plumes will rise to the top, and this will simulate the same process that will happen in our solar collector. When the sun radiates on the collector, cold water will get heated and hot water will rise to the top in our storage tank. Before we can do our installation on the roof, we need to check some components during our site investigation. One of these are the inclination of the roof. We also need to check whether our roof is strong enough to carry the weight of the solar system. For Mrs. Tahiti's house, we only have 3 individual timber beams, and this means that we will definitely have to strengthen our roof. This template over here is just a simulation of the roof structure that we have, and we would then have to install extra timber support onto our roof structure to make it stronger so that we are able to carry the weight of our solar system. In order to carry the weight of our solar installation subframe and components, we will have to reinforce our roof. Firstly, we will use an extra timber member towards the base of an existing beam to give it extra support and strengthen it. Secondly, we will have to add 2 extra structural timber members to the top section of where our installation will be done. Added to this, we will have 1 timber member that is running perpendicular to the 2 that have been installed to give us the necessary support on the top section of our solar installation. Our solar thermal installation is now complete in accordance to our prescribed manufacturer guideline, and we've ensured that the position of our solar collector is perpendicular to the sun. This ensures that we get maximum radiation onto our collector, which will improve the efficiency of our system. After installing our solar system onto the roof, we have installed our hot and cold water pipes to and from the system. After we did that, we have commissioned our system, tested for leaks, and are now ready to hand over our system to the client.